During the period 1886 and 1902, two physicists, Wilhelm Hallwachs and Philip Leonard, carried out a thorough investigation of the photoelectric effect phenomenon. Leonard conducted an experiment in which he placed two electrodes, an emitter or cathode, and a collector plate inside an evacuated glass tube. He connected the collector plate through the cathode by a wire through a sensitive ammeter to measure any current in the circuit. He then allowed ultraviolet ray radiation to fall on the cathode or emitter plate. As soon as the ultraviolet radiation fell on the cathode, a current flowed in the circuit, which was measured by the ammeter. He also observed, as soon as the ultraviolet radiation was stopped, the current also stopped flowing in the circuit. It was evident from the experiment that as soon as ultraviolet radiation falls on the cathode plate, it emits electrons. These electrons are attracted by a positive collector plate and start flowing towards the collector plate. As a result of the flow of the electrons inside the glass tube, an electric current is observed in the external circuit. For this, studies of this phenomenon were carried out by Wilhelm Hallwachs through a very simple experiment. He mounted a clean, circular, negatively charged zinc plate on an insulating stand and connected it by a wire to a gold leaf electroscope. He observed that when ultraviolet radiation was incident on the negatively charged zinc plate, it lost its charge. Also, he repeated this experiment by replacing the negatively charged zinc plate with an uncharged zinc plate. The uncharged zinc plate became positively charged when ultraviolet radiation was incident on it. Moreover, using a positively charged zinc plate in the same experimental setup further enhanced the positive charge of the already positively charged zinc plate. From the various observations of his experiments, Wilhelm Hallwachs concluded that negatively charged particles were emitted from the zinc plate under the action of ultraviolet light. Wilhelm Hallwachs and Leonard also observed that no electrons were emitted by the surface when the frequency of light was less than a certain minimum value. This minimum frequency of incident light, below which no photoelectrons are liberated from the metal surface, is known as the threshold frequency or work function. Threshold frequency depends on the nature of the metal surface. Certain metals, such as zinc, cadmium, and magnesium, respond only to ultraviolet light, as they have short wavelength and high work function. Whereas alkaline metals, such as lithium, sodium, potassium, cesium, and rubidium, are sensitive even to visible light. Such metals, which emit photoelectrons in visible light and have a very low work function, are known as photosensitive substances.